Without using calculus, sketch the following polynomial function showing the behaviour near any x-intercepts. P of x equals -2 multiplied by x plus 2 all squared multiplied by x minus 1 all to the power of 5 multiplied by x plus 1. First, find the leading term. -2 multiplied by x squared multiplied by x to the power of 5 multiplied by x, and this equals -2 times x to the power of 8. The degree is 8, so it's an even degree with a negative leading coefficient. The graph will stretch from quadrant 3 to quadrant 4. Next, we find the constant term. -2 multiplied by 2 squared multiplied by -1 to the power of 5 multiplied by 1, and this equals 8. So therefore the y-intercept is 8. Next, we find the zeros and their multiplicities. X plus 2 all squared equals 0, and the solution to that is x equals -2, and its multiplicity is 2. X minus 1 all to the power of 5 equals 0. Its solution is x equals 1, and its multiplicity is 5. And finally, x plus 1 equals 0. Its solution is x equals -1, and its multiplicity is 1. Finally, we sketch the graph. So I've drawn part of the graph here. Here are the zeros, so there's -2, -1, and 1. Now, the 0 at -2 has multiplicity 2, so the curve will bounce off the x-axis. It'll be tangent to it, it'll touch the x-axis, but it'll bounce off it. Also taking note that the curve will stretch from quadrant 3 to quadrant 4, so this is why this arrow is here. This is quadrant 3, so it's like as if the curve's starting from quadrant 3 and it ends up here. So clearly, the curve will bounce off the x-axis here. Now, in quadrant 4, so I'm sort of going to the other side, starting from this end, going backwards, okay, the 0 at x equals 1 has multiplicity 5, which means that it'll cut through the x-axis. The curve will pass through it, but it'll pass through it like kind of like as if it's a cubic curve. So it'll be tangent to it as well, hence it'll have this shape. We have the y-intercept of 8 there, and obviously we have a 0 here at -1, and its multiplicity is 1, so it'll behave like a linear function. I'm going to complete the curve now. So here's the curve now completed. It's not to scale, and far from it in fact. In fact, to find any of the turning points accurately, you'll need to use calculus or some other method, of course, but this answers the question.